Hello guys, welcome to Bugs in Code, and today we are going to look at a very nice problem, that is wall coloring. But before that, if you are new to the channel and the person who likes stuff related to coding, then this is the place for you. Subscribe the channel so that you never miss out an update. So let's move to the problem statement first. The problem statement says that there is a row of n walls. Okay, so I have n walls up to n, and in the geeks land, the king of geeks land ordered Alexa to color all the walls on the occasion of New Year. Alexa can color each wall with either pink, black or yellow colors. So for any wall, let me change the marker here. For any wall I have three options: either I can color it with pink or with black or with yellow. Okay, so the cost associated with coloring each wall with a particular color is represented by a 2D array colors of size n cross 3. So we are also given an input array of size n cross 3, n cross 3, and here the row represent a wall and the column represent the color, the cost of coloring a particular wall with the particular color. Okay, so you need to find the minimum cost to color all the walls so that no two adjacent wall have the same color. Okay, so we cannot have the same color for two adjacent walls. So let's take an example here. So let me take an example. The example is 14 to 11, 11, 14, 5 and 14. And so there are basically three walls, and for each wall I can either color it with pink or with black or with yellow. So for the first wall, when I'm at the first wall, then I can color the first wall with okay, black color, and for the second wall I can color it with yellow color, and the third wall I can color it with black color again. So in this way we are not having any two adjacent wall that have the same color, and we have colored all the wall, and the cost is given by for black color first wall 2 plus for yellow color for the second wall is 5, and similarly for the third wall is 3, and the answer in this way is 10. We can also try another combinations, like what about first wall with pink and the second with black and the third with uh, yellow. So pink plus black plus yellow, so we can have different solution. 14 plus 10, and it is going to give me 38. And there are other options as well, but in all the options the minimum possible cost is 10. So how I'll get the minimum possible cost? If I color my first wall with black, the second wall with yellow, and the third wall again with black, so I'll get the answer as 10. So let's move on to the solution of the problem. Okay, so I'm going to write the same example again here. The example is 14 to 11, 11, 14, 5 and 14, 3, 14, 3 and 10. So the way I look into this problem is a kind of recursive way, like at each point I have to make certain decisions. So let me draw the wall so that you can understand easily. Currently I'm at the first wall, and for the first wall I have three options. I can either color the first wall with pink color or with black color or with yellow color. So by coloring with pink color I get the cost as 14, coloring with black I get the cost as 2, and coloring with yellow I get the cost as 11. For this pink, how many options I have? For this pink, if I have colored this wall with pink color, then I cannot now one more thing to write is, now I am at the second wall. So how many options I have to color second wall if I have colored the first wall with pink color? So I can either color with black or I can color with yellow, but pink cannot be here because we cannot have any two adjacent wall with same color. So when I color it with black color, then I have 14, then my cost will be something like 14 plus 14. And similarly for this y, actually I should write 28 directly. Similarly for pink plus yellow combination, so pink is here and yellow is here, it is 14 plus 5, that is 19. Now for this black, if I have colored the first wall with black color, then for the second wall I have options like pink and yellow. So if I do pink color, then I have 2 plus 11, that is 13. Black for this and pink for this, okay. And when I color with yellow, then I have 5 plus 2 7. When I have colored the first wall with the yellow color, I mean this wall with the yellow color, then I have options to color my second wall with either pink color or with black color. So when I do it with pink color, then my total cost will be 11 plus 11, that is 22. And if I do it with black color, then 11 plus 14, that is something like 25. Now I came to my third wall, and this is the last wall that I'm going to color. So for the third wall, for B, I have option. If I have colored with black color, then I have option like either I can color with pink or I can color with yellow. So if I do it with pink, then I'm going to have 14 plus 14 28, and 28 plus 14 42. And if I do it with the yellow color, then I'm going to have 28 plus 10 38. Similarly, if I have colored my wall with second wall with pink color, then I can either color with black or with yellow. So if I do black color, then I will have cost 13 plus 3, that is 16. And if I do it yellow, then 13 plus 10, that is 23. Now for this yellow, I have two options. I can either pink color with pink or with black. So if I color with pink, then I have the cost 7 plus 14, that is 21. And if I color with black, so I have cost 7 plus 3 10. Similarly for this pink, I can either color with black or with yellow. For black, cost I have cost 11 plus 22 plus 3 25. And for yellow, I have cost 32. Similarly for this black, I have option either pink or yellow. So for pink, I got my cost as 25 plus 14, that is 2 class 25 plus 14 is something like 39, I guess. So it is 39. And for this yellow, I get 25 plus 10, that is 35. Now this is the whole process of coloring the walls, and in this process we can see that if I go along this path, then I have the minimum cost possible. So this path says that, hey, why don't you color your first wall with black color, the second wall with yellow color, and the third wall is with black color. So this way I am going my minimum cost as 10. So this is kind of recursive problem. If I am given n walls and I have the cost matrix something like 14 to 11, 14 to 11, 11 14 5 and 14 3 10, 11 14 5 and 14 3 10. So what I can do is I can have my pointer here, and after that I can move my pointer and make choices like which color to do. But here I have to keep track of my previous color, previous color. So before moving on to the coding section, let me tell you why I need to keep track of my previous color, because we are not going to have two walls with the same color. So to avoid this thing, we need to know that what is the color of my previous wall, and we are not going to color my current wall with the previous color. So this is all about the solution. And one thing that I can notice is, if I color this wall with black, and after that I can have my, okay, so let's code this approach first and then we'll see. So this is a problem at Geeks for Geeks, and we are going to code this problem. So this is the recursive approach that I am going to have. So I have three options for the first wall. The option one is I can either color with the pink color, and then I'm going to color rest of the walls. And in the, I'm also going to have one variable that is previous, the fourth one, and in the previous I'm going to have 0 because I have colored pink. Similarly, I am going to have option 2, and it is going to color with black color and do color 1. See, we have to move our pointer, we have to start our pointer with 1 because we are already coloring our first wall here. So we can have third option like coloring wall with the yellow color, moving pointer, and at the end I have to return the minimum of all these options. Like we have three options, I can either color my first wall with any of the colors, so just return the minimum of these options. In C++ we have a function that directly finds the minimum of multiple variables like min, option 1, option 2, and option 3. So now let me code how it is going to perform the color for rest of the walls. I mean do color function. Do color. I have one moving variable that is iterating all the walls. Then I have colors. Then I have the size of the wall, total, the count of total walls, and this fourth one is previous. Okay, so if I have colored all the walls, then I have to return 0. And if my previous wall was pink, then I have to do something else. If my previous wall was black, then I have to do something else, and else my previous wall must be yellow here. So okay, what if my previous wall is pink? So I can either color with black, so either color with black or with yellow, but not with pink. So I can return minimum of the color. Okay, so I have to add the cost of coloring the current wall with the black color first. So black color, index for black color is 1, and then I'm going to move to next wall, and now my previous have become 1 because I have colored with the black color. Similarly, I can also color the current wall with yellow as well, and this way I'm going to move to the next wall, and also I'm going to change my previous variable to 2. So let me copy this because same structure is going to be followed for other as well, but for this I'm going to color with pink or with yellow, right? And for this I'm going to color either with pink or with black. So it will be 1 and it will be 0. It will be 0 here. So this is the recursive approach, and let me run this approach. It should work, I think. Okay, so it's working, and let me submit this. It is going to throw time limit exceed because the approach is taking too much time since I'm calling a function 6 times. So let's see what else we can do in order to optimize this approach. So we are done with our first approach, that was recursive, and let's see what optimization we can do. So if we see this decision tree, then we can, okay, so let me see how it is working actually. I have colored with pink, and then I'm going to color with black. So it is something like, when my do color was called for I plus 1, and the previous was the previous was 0, or do for I plus 1, previous was 1, and do for, okay, so one thing that I can notice here is, let me show you what I'm observing. When I call my function for let's say I have colored with pink and I have colored with black here, so I can here either color with black or can color with yellow, and I can here either color with, so suppose here we have 4 wall and now we are going to color 3 walls. So we are going to color 3 walls with either pink color or yellow color, but the problem is we are solving the same sub problem again and again. So it looks like we can save this. So now we found something that is overlapping sub problems, overlapping problems, and we have already seen that here, that we have something like subproblems. Since a problem can be divided into subproblems, so we can apply dynamic programming here. We can apply dynamic programming here. Okay, so now it's getting very interesting how we can apply dynamic programming. Since we have already coded our recursive approach, so we just need to apply memoization. So let me declare my integer array dp, and it is going to be a 2D array. Why 2D array? Because it's going to 2D array because at each point we have to store our item previous color and also the current index, that is the current wall that is going to be colored. So it is going to be of size n and 3. Now let me write, if my dp of ij is not null, then I'm going to return my dp of I. Okay, it should be previous year instead of j, and here whatever the answer I am returning, I'm going to store the answer in my dp array. Similarly for this, and similarly for this as well. Okay, so let me check whether it is working or not. It is working for the example test case, and now let me submit the solution. Okay, so it worked, and this is all about this problem, but I think let me write tabulation approach for this problem, because tabulation is something that is consider to be more optimal. Why? Because it saves the extra stack space that is going to be used here when we call this function again and again. So I'm going to code the tabulation approach for this problem as well. Tabulation. Okay, so let's see how tabulation is going to work here. What we can do is we have our dp array here, and we can initialize our dp array with. Okay, so let me explain the tabulation approach first here. What I'm going to do. Okay, so tabulation approach, we have n walls. For simplicity, let's consider 5 walls. We have these five walls. At each point, what I'm going to store is I'm going to store what the minimum cost of at each iteration I am going to store the minimum cost of coloring I walls, first I walls with particular color. Like my DP is going to have 3 columns, and my I have a DP array that is going to have 3 columns and some rows, let n rows, because we are going to color n walls. So at each row I'm going to store the minimum cost of coloring the first I elements with the first color, pink, black. So this cell is going to store the minimum cost when I color my current wall with pink color. Similarly, this is for black color and this is for white color. So let me write here dp of I and color stores the minimum cost, store the minimum cost of coloring first I walls with the particular color, which is actually color here. Okay, so now let me code the approach for the first wall. What about the first wall? For the first wall, I'm simply going to store dp of 0 0 will be simply equal to color of 0 and 0. dp of, I'll explain what I'm doing, 0 and 1, and dp of 0 2 is going to be color of 0 and 2. Okay, so let me show you what I have done for the first wall. Let's take, I have only one wall. So what is the cost of coloring this wall with pink color? Whatever, so this cost will be equal to whatever the cost we are given in our colors array. Simple. So similarly, for if this is black, then we are going to take the value from colors array, because we have only one wall, so we don't have any sub problems here. But what about we have colored, let's take, we have colored first 3 walls with any particular color, and we are at the current wall I. So for coloring I with particular color, let's take pink color, I need to check the minimum of coloring the actually pink color here is coloring the wall with black color and yellow color. So whatever is the minimum of these walls I'm going to take here, and after that I'm going to add the color of coloring this particular wall. So let's move back to the code. So I'm going to run a loop from I is equal to 1, and I'm not going to n because I just have to color the n minus 1 walls. I'm starting from 0. And okay, so dp of I and 0, it what it represent actually the minimum cost of coloring the current wall with the pink color, I minus 1 1 0. So it says that, hey, if you want to know the minimum cost of coloring the current wall with pink color, so you just tell me what was the minimum of what was the cost of coloring I minus 1 wall with yellow color and black color. So, and after that I'm also going to color my current wall with pink color, so I'm also going to add that value. Similarly, dp of I1 is equal to colors of I1 plus minimum of dp of I minus 1 and 1. So it will not be 1, it will actually 0. And okay, so what about coloring with yellow color? I hope you guys don't have any problem when I say color with that is indices. Like pink color is represented by 0 index and black color is represented by first index, and the yellow color is represented by second index. So coloring the current wall with yellow color, I'll simply do minimum of I minus 1 and 0, and then I minus 1 and 1. Okay, so now I have colored all my walls with I have checked all the possibility of coloring the walls, and at the last I will return what is the minimum of coloring n minus 1 walls, no doubt, with all the colors. Like I can either color my last wall with 0, or I can color with 1, or I can color with 2. So that way I'm going to return, and let me check whether it is working or not. Okay, so it is showing me compilation error. Now let me check again. I think it should work. Okay, the example test case is working. Now let me submit the solution, and okay, it works. So this is the tabulation approach for the problem as well. So this is all about this problem. Okay, so I think I can do better. I can, instead of writing mat.min again and again, I can simply write arrays dot stream dot min dot. So I think this is more simpler. dp of n minus 1 0 and dp of I think it should also work. Okay, so it's working as well, and this is all about this problem. If you like the solution, then you can hit the like button, and this is all about the solution. So thank you guys.